Hey guys, welcome back to another video. In today's video, we are going to be having a look at some computer science past papers in preparation for the Feb-March series. That's just coming up in a few days. I believe it's 11th February. I think that's when paper 1 is, if I'm not wrong. But yeah, so basically in this live stream, okay, I am just going to be covering some past papers, going through some questions. And yeah, you can follow along. Also, after the live stream ends, you can also have a look at the questions that I've done in the live stream. So without further ado, I think let's just begin. We're going to start off with Feb-March 2021. And I've done some other past papers in my channel, on my channel. So that will be all down in the description, so you can have a look at that. So with that being said, let's just get into the video. And we're going to start off by solving the Feb-March 2021. Paper 1, 2. So yeah, let's begin. So usually the first question is always conversions, either binary, denary. It's usually always, just simple conversions that, it's just basic stuff, okay? And if you haven't checked out my conversion video, it will be somewhere on my channel. I think it's the first video or something. Go and have a look at that. It's a really good, simple walkthrough, so you can have a look at that. Okay, but yeah, I'm not going to be revisiting the topic. In this, the main purpose of the video is actually just to do the question, and we'll not waste time like that. So yeah, let's begin. So the first question: a hockey club records the number of people that watch each match. An 8-bit binary register is used to store this value. So an 8-bit register is now used to store this value. It is saying 46 people watched the first match, okay, and 171 people watched the second match, okay. It says show how the register would store these denary values as a binary value. So we have to basically convert this 46 into binary. So it's as simple as that. Now the technique to do this, okay, is I usually like to list out the numbers. So 1, 2, 4, 8, 16, 32, 64, 128, yeah. And basically with these numbers I have to construct 46. So that's how it works, okay. That is how it basically works. So let's see, to make 46 we can use 32, okay. Let's see, 32 plus 16. 32 plus 16 is 48. So 40, we can't use 16, so that'll be 0. Let's see, 32 plus 8 will be 40. We'll use that. And then 1, 1, 0. The rest will all be 0. Okay, so that's how it works. Basically, wherever there's 1, that's the only value you'll count. So if there's 1 here, 32 plus 8 plus 4 plus 2 should give us 46. So now I'll just write that here, okay? And this is 8-bit, that's why I reached only till 128. But you can keep going on. Okay, so that is the first one done. We move on to 171. 171, it's the same principle. Again, if you have any question, feel free to go to the comment section and I will respond as soon as possible. Okay, so yeah. Okay, we move on. So 171 is the same thing, same process. To make 171, let's do what, 128, I believe. Yeah, let's add 128 first. Okay, then we maybe can add 64 or say, let's see, because you're not allowed to calculate it. That's why you have to do it manually, which is a bit annoying, but you should get used to it even when practicing with the paper. So we can't use 64 because it is more than 171. So let's use 32. So we do 128 plus 32. That will be basically 160. So we'll use it. Then we have 16, 8, 4, 2, 1. Okay, let's see, we need how much more? We need 11 more. So we won't be needing 16. I'm thinking 8 plus 2 plus 1. Yeah, that should be correct. Yeah. So, oh, sorry. Yeah, 8 plus 2 plus 1. Yeah. So now I just write the binary values here. So it's as simple as that actually. It just basically, to get these numbers, I'm just doing 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, and so on and so forth. Because binary, remember, it's base 2, okay? That's why it's 2 to the power. For any other one, it will be 16 to the power, okay? For like hexadecimal, it will be 1, 16, 256 or something like that. So that's for hexadecimal. And for denary, usually it's not tested for denary, but you should also know for denary. Yeah, so where were we? So 11010 sometimes these numbers can be confusing. So yeah, but then I think once when you get the hang of it, it becomes easy. Okay, so yeah, that is the first one done. If there's any mistakes, please feel free to comment down below. I am doing this live, just like you guys, if you are doing this live. So yeah, tell me if anything is wrong, but I doubt, because I'm having a look at the marking scheme as well as doing this, so I don't get it wrong. So if there's any problem, if I've missed something, just let me know if you're watching this live. Okay, so that being said, let's move on to B. It says, give the largest denary value that can be stored in an 8-bit binary register. When it's an 8-bit, so basically everything is 1, okay? Okay, everything here is like, it's 1, 1, 1, 1, 1, 1, 1, 1. What will all of that be? So this is a big calculation. It's only 1 mark, because some people actually just know it offhand, but, I think it's 255, but if you didn't know it was 255, you would have added 128, 64, 32, 16, 18, 4, 2, 1, and you will get 255. But I'm just going to skip it for the sake of saving time. But what you're supposed to do is you are basically supposed to add all these numbers. 1, 2, 4, 8, 16, 32, 64, 128. If you add all of them, you will get 255. Okay, C is saying the hockey club wants to increase the number of people that can watch each match to 2000. So they want to make it to 2000. The 8-bit register may no longer be able to store that value, of course, because it's 255 is the largest. Give the smallest number of bits that can be used to store the denary value of 2000. So that means, how many bits do we need to get that 2000? So okay, after 128, what's after 128? It's 256, I believe. It's 256, right? After 256, it's 512. I don't know. Okay, this is actually going to take us a lot of time, because what you're supposed to do, right? So this is 0, 1, 2, 3, 4, 5, 6, 7. So this, right now, we're currently at 2 to the power 8. We have to do 2 to the power 9, 2 to the power 10, plus 2 to the power 11, and to see how many we have to go on to get us to 2000. Okay. Now, of course, plus 255, which was the previous ones. So basically, this question is asking us how many. You see, in this question, it's an 8-bit register, meaning it only goes to 128, meaning the largest value is only 255. It's asking us how many bits do we require to make it 2000. Okay, how many bits is required to make us 2000? So it'll be basically like 255 plus 256 plus 512 plus, I'm sure whatever this is will be greater than 2000. So the answer should be 11. Okay, because after 512 it'll be 1000 and something. So we know this is 500, this is 500, and then plus 1000 should be greater than 2000. So it's most likely 11. Okay, so that's how you do it. Let me just have a look at the comment section if there's anything, the live chat. Okay, yeah, so that's that. Okay, the next one. An electronic data about the final score for the match is transmitted to a central computer 30 kilometers away using serial transmission. What is serial transmission? Serial transmission is basically when data is sent over a single wire, and usually you use serial transmission over long distances. That's why it's saying 30 kilometers away. So it's saying, explain why the serial transmission is more appropriate than parallel transmission. Okay, now when it's telling the disadvantages, I know it's not asking us for the disadvantages, but parallel is it's way faster than serial. But serial, of course, has its advantages, and one of them is because of its long distances. Okay, now what you write here is, first of all, serial transmission is reliable, okay, over long distances. Okay, it is way more reliable over the long distances. So that's the first point that you would write. Okay, the next thing is that the data, okay, that once when you send in the start, will arrive in order. Data will arrive, okay, will arrive in order. Okay, that means that the data that I've sent, when it's receiving, it will be in that same order. Okay, and that's how it's done. Okay, and the last point that you give for the 3 marks, remember, every time you always look at the marks. You know, in computer science, the trick to these types of questions is look at how many marks it is, and that's how many points you required. Okay, for example, you know, if it's telling you to talk about MIDI, the first mark would always be to tell us the full form. Okay, HTML, tell us the full form. HTTP, tell us the full form. Okay, even if the marking scheme does not award you a mark, it's always safe to put that, you know, full form. Okay, even if it's not in the marking scheme, it's always safe to put it, because, you know, 95% of the times they will give you a mark for that. Okay, they usually, even in the marking scheme, most of the times for that full form you will get 1 mark. So always write the full form. The next thing, write the definition. The next thing, write how it's created, you know, something like that. So it's basically the point system, and that's how you earn marks. If you want to be, you know, getting way more marks, that's the real trick behind, you know, computer science. So that's what I would advise you to do. Okay, so the trick would be basically to look at the marks and then name those points. So if it's 3 marks, say 3 points. Okay, so in this one, also you can say that serial transmission is way cheaper than parallel. So that's another one you need to know, and these ones, you know, you just need to revise them. Okay, there's no any shortcut to this. So serial transmission is cheaper compared to parallel transmission. Okay, because of course it's single wire, you know, you don't need that much, you know, whatever materials or something like that. So but what you need to know, all you need to know is that it's cheaper. We move on to the data transmission is also half duplex. What is half duplex? Half duplex is basically in both directions but not at the same time. So when data is sent in both directions but not at the same time. Okay, so it says describe half duplex data transmission. So let's describe it, just what I really just said. Okay, so this is basically transmission. Okay, this is basically transmission, okay, in both directions, but, okay, you have to write this, but not at the same time, because if it's at the same time, then that is not half duplex, that is full duplex. Okay, so but not at the same time. So you have to mention this. Okay, you have to mention this. So yeah, that is that. We move on. It says the data transmission uses checksum. So the data transmission uses checksum, and I'm really sorry if my live stream is buffering. The Wi-Fi is not that stable, but I am assured that after the video is uploaded, the buffer will go, because it's mainly on the visual skills, not the audio. So if there is any buffer, it will go once when it's uploaded, so don't worry. Okay, it says the data transmission uses checksum. Checksum is basically another way to, you know, identify errors. Yeah, so it says describe how checksums are used to detect errors in the data transmission. Again, it's 3 marks. Always look at that. 3 marks, 3 points. So let's see. Point number 1. First of all, look at the question. The question is telling us, okay, the question is telling us, how are these checksums used to detect the errors? How are these checksums used to detect errors? Okay, that's the first thing. So meaning our 3 points have to be related to how they detect errors. Okay, the first one, you know, checksum, coming from its name, checksums, meaning it calculates a value before it is sent. So basically you can just say calculates. Okay, you can say calculates a value from the bits. Okay, so from the bits it will calculate that value. After it calculates that value, the value is then put next to that checksum. So basically you can say value is, basically the value is appended. Okay, you can say, or added, appended to the bits or the data. Okay, and finally, once when it's transmitted, okay, the receiver will recalculate bits and see whether they match, and if they don't match, then they will resend it. Okay, and if it matches, then it's successfully done, there's no errors. But if it's not matching, then there's an error. So that will give you 3 marks. Simple as that. I'm gonna keep checking the chat if there is any question. Okay, so yeah, we move on to number 2. Number 2 says Gurdeep takes high definition photographs using a digital camera. Okay, using a digital camera, she has to set up a website where the users can view thumbnails of a photograph. So basically, she's setting up a website where she can see basically photographs, and the thumbnail is a small version of a high definition photograph. Okay, so basically it's trying to tell us that she's uploading photos onto that website. It then says Gurdeep compresses the high definition photographs to create thumbnails. She uses lossy compression. So here's the keyword, lossy compression. So we have two types of compression in the IGCSE syllabus. We have the lossy compression and we have the lossless compression. The difference that you need to know between the two is that lossy compression, the data is lost forever, and lossless, it is not lost, okay, in simple terms, okay? But, you need to read further on this to look at more of the differences. Now, it's saying, describe how the lossy compression creates the thumbnails. Now, I like these questions because, in computer science, so many of these questions are just repeated, okay? Maybe like next year or in this Feb-March exam, you'll be told, describe how lossy-less compression creates thumbnails. It's so similar, just they've twisted one word in the question, okay? So for this type of question, usually, always, okay, when you're talking about compression or how compression is done, the first step you have to always write, this is the easiest 1 mark you can get, you have to mention that a compression algorithm is used. Boom. That will give you 1 mark there. It's as simple as that. It will work for lossy-less, it will work for lossy. Okay, whenever it asks you, identify or tell us why or how compression works, just mention this and you'll get your mark. Mention this and you'll get your mark. Okay, then number 2. Okay, now we talk about lossy compression. First of all, I told you lossy compression, no data is lost. So, lossy compression, data is permanently lost. So you write that data is permanently lost. Okay, so it's permanently lost. So that will give you the next mark. And number 3 is that you can also say that how the compression works now, because of course, data, how is it compressed? Compression is basically when you're compressing the data, right? So if data is permanently lost, that means that something has been compressed. So how does it work? It basically works by reducing maybe the pixels, reducing, let's say reducing bits per pixel. So we can compress the data. Okay, I'll give you 3 marks. You can also mention something about reducing image resolution or something like that. Okay, that will give you your marks. So let's see here, we have Gurdeep, who sets the web server to host their website. She reads about an internet protocol. IP address. What's an IP address? IP address is a unique address given by the ISP. What's the MAC address? MAC address is the media access control. This is basically set by the manufacturer, and this is basically also unique to every device. And of course, it's made by the manufacturer. The URL is basically, we all know URLs. It's used for web pages to locate them. Universal resource locator. So let's see. IP address. IP address looks something like this. The MAC address looks something like this. Look at this. The first part of it is actually a manufacturer's code, meaning it's always the same. The URL, we all know, is that. So that will give you 2 marks. If you get any wrong, you'll get minus 1 mark. Okay. But this one, these matching questions are really easy, So yeah, we move on to the next one. The next question is something related to SSL. You need to know about TLS and you need to know about SSL. Okay, so, but if TLS questions come up, I will talk about it. But again, right now is not a sort of talk about through every topic, but we'll have a look at it topic by topic. But we're going to try to do as many questions in today's live stream. Okay, the main purpose of the live stream is to, if you've revised, this is the perfect video for you. Okay, we're just going through questions and explaining, clearing doubts and everything like that. Okay, so let's see. Users can buy a high definition photograph from the website. When a user buys a high definition photograph, a secure socket layer connection is created. Okay, so SSL basically works to the help of certificates. So basically what happens is that when you enter into a web page, okay, the user will basically ask that web server to identify itself with the help of the certificate. Okay, then that web server will send that certificate to the user. The user will check the authenticity of that certificate, and if it's authentic, then the transmission will begin. Okay, meaning the connection will be successful. If it is not authentic, then it will blacklist that website. Okay, so that is how it works. And if it is authentic, then something called a session key is generated, and that's basically how SSL connection is done. Okay, so even when you're using your web page, maybe you have a sort of software. This software will do the SSL, meaning you will know that they're asking for a certificate, but in the background, when you're loading that web page, all that is happening. Okay, all that is happening in the process. Okay, so yeah, give one benefit of SSL connection, you can say data is encrypted. So what that means is that people will not be able to get your data. Okay, once when it is got a secure connection, no one can break through it. That's the main point of the SSL connection. Once when there is basically a secure connection, then no one can go through it, meaning no one can steal access because that data is encrypted. Okay, so yeah, that is that, and we move on to the next question. Okay, the next question is telling us, explain how SSL connection is created. We need 4 points because it is 4 marks. I've talked about so much about SSL. First of all, I said that SSL connection, okay, the first thing I said was it uses certificates. So you just write uses digital certificates. Okay, there's no physical certificates, but even if you don't write certificates, you'll still get it right. You're not that strict. The next one is that this is requested. You can write requested by the client or by the browser. That'll give you another mark. Okay, then you can say that it's actually a big long process. You can just say the browser checks the authenticity. This is actually what I was just saying previously was actually what the marking scheme says also. The same exact words, authenticity. Okay, so once when you do so many computer science papers, it automatically, those words that the examiners want you to write, it automatically comes. So do many past papers. That would be my tip. Okay, so the browser checks the authenticity of the certificate. Of course, I'm just going to put ... And then finally, the session key is created. So session key is generated or created or whatever you want to say. Okay, we move on to question 3. Question 3 seems to be something on input and output devices. I think this topic never misses out, and it's such a big topic. It's such a wide topic, meaning there's so many devices, you need to know them. Okay, and most of them just revolve around projectors, 3D printers, scanners. So you need to just microphones, you need to mouses, you need to have a look at all of that. Okay, so let's see. Uses thermal bubble or piezoelectric. Once when you ever hear piezoelectric, okay, when you hear piezoelectric, you already know it's an inkjet printer. I've spelled that wrong. 1 second. So it's basically an inkjet projector. So I'm just going to write an inkjet projector. And then actuator. What's an actuator? Actuator is simply operated by signals to cause a physical movement. So that is the work of the actuator. It's as simple as that, basically. So this is so that we can make cause physical. So we can cause physical movement. Okay, so we can cause physical movement. Okay, that's the main purpose of the actuator. Okay, we move on. Yeah, that's basically all about actuators. They cause basically physical movement, and you can also give an example. Like, for example, your RC car is actually run by an actuator, because that machine that spins those wheels are actually done by the actuator. So that is done by the actuator. We move on to uses thousands of tiny mirrors that can move very quickly to create an image. So whenever you see tiny mirrors, and many of them, you know it's a projector. Guess that it will be a projector. And the mouse would be basically an optical sensor. Okay, so the mouse would use an optical sensor, and you can also mention that it would use laser for movement. To basically use laser for movement. Can you give an example again? And basically the movement is echoed onto the screen. So we move on. Okay, the next question is a question on microprocessors, I believe. Or actually it's a barcode, never mind. Barcode. So the barcode ones. So there's a lot to talk about barcodes. You also need to know the difference between the barcode and a QR code. You need to have a look at So the difference is basically between the barcodes and the QR scanner is that the barcodes are vertical lines while the QR code is in a square form. Okay, now let's see, but in this question we're talking about only barcodes. So we'll basically just have a look at barcodes in basically right now. So let's have a look at barcodes. The first thing, so it's 6 mark, meaning 6. Basically, if it's 6 marks, meaning we need 6 points. We have talked about this. So let's see. Explain how the barcode is read at the supermarket checkout and how the price of the product is found. So let's see. Number one. Okay, number one, how the barcode scanner works is basically it will scan it, of course, because you know it's literally called a barcode scanner. So first of all, it scans. So after it scans using the barcode reader, the next thing what it does is that it scans this using something called the red light or the red laser. So you know that the laser that you see on your mouse when you're using it, it's the same laser that is done on the barcode. And number three is that the light will be reflected. So you write light will be reflected, and that's how it reads the data. After that, the different reflections will give different values and different binary values, and this is then converted into digital values, and we are created your data that will be inputted into the program or wherever you're storing it. So let's write that right now. Okay, and then number 5, we are going to write that microprocessors will interpret this data and then finally execute the data. So it's as simple as that. So we're going to quickly write microprocessors will interpret this data. And I think I've given more than 6 marks. You know, it's just because like you get marks also when explaining. So that's how, you know, it just basically just works. So even when explaining, you will get the marks. So that's how basically it works. Yeah, so that's how it works. Then we move on, we talk about let's see this. So the supermarket stores data using solid state, which is SSD. We know we have SSD and we have HDD. So it's basically telling us to explain how an SSD stores data. So how does an SSD store data? So let's now talk about how an SSD stores data. So SSD stores data using something called the flash storage. So it uses the help of flash storage, and then this flash storage is basically used. So you can also mention that it uses the NAND gate. Now you see, for most of these questions, I think you just need to know, you need to understand it, and that's how you basically get marks. You just need to revise through the help of theory. Okay, and then finally you can also mention that they basically, when you can say that what can you say, let's see, it uses, yeah, there you go. So it uses transistors. So it basically uses transistors to get that SSD. Okay, to get that SSD, it uses the help of transistors. And yeah, okay, so there basically it uses transistors, and that is how it works. So let's see, one advantage of an SSD rather than an HDD. So why would you use an SSD rather than an HDD? Is that it has no moving parts, so hence it's more durable and reliable. Another advantage you can say using SSD rather than HDD is SSD uses less power consumption. So you can say less power consumption and you'll get a mark there. The next question, logic gates, always tested in paper 1. Logic gates always tested. You will be expecting this also in your, the current exams and all. So basically here you're given a truth table and you're supposed to guess your logic gate. So in this type of question, I would personally, I'll do the trial and error. So what you're supposed to do is yeah, let's see, you just test each gate. So let's see, first of all, let's start with the AND gate. Maybe the AND gate, let's see, AND gate is basically the multiplication gate. So that means we can multiply and see, and I can already tell it's wrong, but it actually can be the NAND gate, because if it is the AND gate, then it will be 0, 0, 0, and 1 here. Now it's the opposite, hence it will be the NAND gate. Okay, so that is how you can determine that. The next one, let's have a look at this. So 0, 0 is 0, 0, 1. Yeah, so this is the XOR gate, and how I know this is that what I like to remember is the like terms is always 0. So like 1, 1 is always 0, and the unlike is 1. So that's why it is a XOR gate. For this one, let's see, 0, 0. So let's try the OR gate first, maybe. The OR gate is 0 plus 0 is, okay, so no, I think it might be the NOR gate. Let's see, if it is the OR gate, it would be 0 here, 1, 1, 1 here. So it's the opposite, hence it will be the NOR gate. So that's how you do these types of questions, using trial and error, and yeah, you will find it like that. Okay, here we have a logic gates question, and so this type of logic gate question is basically using the help of statements to make your logic gate. So we're going to be using statements to make that logic gate. So let's see, it's actually quite a long paper compared to the other papers, because usually I finish in 30 minutes one paper, but this one seems to be taking a bit longer, more time, but it's fine. So we move on. So let's begin. So let's start. So it says an airplane has a warning system, okay, that monitors the height of the airplane above the ground, whether the airplane is ascending or descending, and the speed of the airplane. So then we are being given height, ascending or descending, and the speed. And then right here we're being told the conditions. So that's the main part right here. So let's start off, and I'm going to do this question by dividing it into sections and then drawing the logic gates. And always check the marks, because if it says 5 marks, meaning we will be needing 5 logic gates. A quick tip is, if it's 5 marks, we need 5 logic gates. Okay, that's a quick tip, and it's always like that. So if you have 6 logic gates, you know you've made a mistake. If you have 4 logic gates, you know you've made a mistake. Here it's 5 marks, meaning 5 logic gates are required. So let's start off. Height is less than 500 meters. So that is my first statement. Height is less than 500 meters, meaning the height is basically 1. Okay, meaning just height. Okay, height is less than 500 meters. The next statement is joined by the aeroplane is descending. So the aeroplane is descending is right here, meaning not A. Okay, because it is not 1, meaning it should be not A. Okay, that's why you will put a not gate here to show that the aeroplane is descending, and this is joined together with an AND gate. Then this entire gate is joined with an OR gate, and this OR gate is then joined by the aeroplane is descending and the speed is greater. So let's see how many gates I see. 1, 2, 3, 4, 5. There you go. Let's see, is it? Yeah, because the final one will be OR. Yeah, so let's see, let's draw this, let's read this, because height, this won't have a logic gate, right? So let's see. 1 second, guys. Let me just plug in the charger. Okay, there you go. So the first one is the height is less than 500 meters. So if the height is less than 500 meters, we saw that it's just 1, meaning we just draw a straight line. Nothing to do with H. This AND, meaning we join it with the AND, aeroplane is descending, so meaning I'll put a NOT gate, because remember here it said it's 0, meaning it's not 1, meaning if it was 1, then I would have just drawn a straight line like this, but here it's 0, therefore I have to say not 1. And basically this is joined with an AND gate. Sorry for the bad handwriting, but this is basically joined by an AND gate. And then the next one is the aeroplane is descending. Let's see, the aeroplane is descending. So it's the same thing. So aeroplane is descending. So what you can do for aeroplane is descending, you can just connect it here. And let's see, so speed is greater than 470 knots. Speed is greater than 470 knots is 0, meaning I'll have to put a NOT gate again. So I'll draw a NOT gate right here. Sorry for the bad writing. Again, I'm doing this on the computer, that is the reason. And this is my AND gate, and this is all joined together with the OR gate. Okay, and you can see we have 5 logic gates, meaning we know we are correct. Okay, so that is how we do it, because you see here it's connecting with an OR gate. That's why I've put an OR gate in the end. For those people asking about the October-November past papers, the ones that just came out, I will be having a look at that maybe in some future past papers videos, but the marking scheme isn't out, so I'll have to go through the questions properly, whether to see if the answers are correct or not, because there is no marking scheme for that. So that one will take a bit of more time, but hopefully we get through it, right? Hopefully we get through it. And hopefully I can upload that October-November one, because exams are coming way close, especially for the Feb-March. So this is the time where you just do past papers. This is the time where you've done your revising, and now it's just past papers. So focus on past papers, you will do well. So let's see, because in computer science most of the questions are actually related. So if you do many past papers, and computer science is actually a new subject because it started 2015, so it doesn't have that many past papers, but even with the available past papers, if you do each and every one of them, you will be ready for the exam. If you're confident that you know all the questions, then you're confident. Even the ones that you're doing with me right now, if you're getting them right, marking them, if you don't understand, there's no problem. Sorry about that. There's no problem. Just have a look at that. So let's move on. So the next question is something related to firewall. I can see firewall here. So let's see. It says hacking is one type of internet risk used to obtain personal data that is stored on a computer. And then it's telling us further, explain how a firewall can help prevent hacking. So we have to basically explain how firewall can prevent hacking. So let's see how firewall works. Is basically it will monitor the incoming and outgoing traffic, and the user will set a criteria, and if that criteria matches, then basically it is allowed. But if the criteria is not allowed, then there is a blacklist. Okay. Or the requirements, if the requirements don't meet, then it's a blacklist. Okay. And yeah, that's how it works. So let's explain that in words now. Firewall, first of all, you need to say monitors incoming and outgoing traffic. That's the first mark. That will get a mark there. Then you can say allows setting of criteria. Allows setting of criteria. So it will allow setting of criteria, and it will block the access to the people that are not meeting the requirement. Okay, but we don't need to try that. You'll get your mark there. Then you can say if does not meet criteria, then user is alerted or warned or something like that. A message is basically given to them. And finally, you can also say will restrict access to some, so restricts access to specific applications. Okay, so that is how it works. Let's see. Identify and describe two other types of internet risks that are used to obtain personal data. So we're looking at personal data and only personal data. So you can't say something related to, not personal data. Like you're gonna talk about, okay, I mean, most of the internet risks are for your personal data, but not all of them. Okay, but you just need to be careful. So let's see. Phishing, farming, spyware, those are all risks, right? So you can say phishing, this is a legitimate looking email that redirects. Now, many times you are asked the difference between phishing and farming, so you need to also know that. The difference basically is that farming is a malicious code, phishing is a legitimate looking email. But other than that, most of it is really the same, because they both have an intention to steal data, and they both use the help of emails to redirect that user. So this is a legitimate looking email that redirects the user to a fake, bogus website. Okay, and then you can say with an intention to steal. Okay, you don't need to write that, but yeah, so you can write that. You can also write farming. I'll write farming. So here I said farming is basically a software that is installed onto the computer. So you can say software, you can say malicious code, but malicious code is basically software. Okay, malicious code / software is installed on user's hard drive or on user's computer and redirects to fake, bogus websites. So 6 marks for that. 6 marks for that. Hello Prem. Yeah, so 6 marks for that. Yeah. So basically in here, 1 mark for farming, 2 marks for explaining. So here the 2 marks I'll get is for malicious code, and then for redirecting to the user. Here I'll get a mark for legitimate looking email and redirecting the user. Okay, and then of course a mark for the internet risk. So we have a question on high level language and compilers and all of that sort. So let's see. Describe what is meant by a high-level language. A high-level language is simply the first thing you would say whenever they tell you to describe a high-level language. You would say close to human language. Okay, so you'd say close to human language. Then you'd also say you can actually say it's portable, because high-level language is portable, if you didn't know. Okay, so high-level language is portable. We move on. So let's move on. Adil uses an interpreter while developing and testing the applications. Okay, and it's saying while developing and testing the application, Adil uses a compiler when application is ready to be shared with the others. Okay, so he's using a compiler when it's ready and an interpreter when developing. So I think predict that we have to maybe show the differences between an interpreter and compiler, or give the features. So here it's telling us to give the features of the interpreter and the compiler. So let's see. So let's start off with an interpreter. Interpreter is basically line by line. Okay, but when you want to talk about, so you can write that interpreter translates data line by line. Okay, while the compiler on the other hand would do it the entire program together. So compiler translates data at one go, or translates the entire code, translates the whole code at once. Okay, then you would say maybe the interpreter, the difference between an interpreter and a compiler: interpreter does not make an exe file, does not create an exe file, which is basically an executable file, while a compiler does. Compiler produces exe file. Sorry for the bad writing. It's just that there's so much to write in computer science, and I'm doing this online, so it's quite hard to actually write them all. Yeah, so Advik, well done. I believe you sat for the October-November for your maths, or is this pre-preparation for your levels? I will be doing some more maths videos in the future, but yeah, we'll see. I'm planning to do more maths live streams, so let's see. Anyway, thank you for having or tuning into the live stream. So let's talk about this. Adil is considering distributing his application as a free software or a shareware. Explain the differences between free software and a shareware. Okay, so 5 marks, so meaning 5 stuff to talk about this. So it's a lot to talk about. First of all, let's talk about free software. Okay, now free software is distributed with the source code. So distributed with source code. It's coming from its name, right? Free software distributed with source code. And then we have shareware does not, by the way. Shareware does not. That will give you 2 marks. The next difference is that free software allows modification, whereas shareware cannot be modified. So free software can be modified, whereas shareware cannot. Okay, that will give you 4 marks. Let's just mention one more. You can also say shareware usually gives a trial period, right? Shareware provides a trial period. Okay, yeah, or it has maybe limited features before having the entire thing. So let's see. The next question is on plagiarism, and it's telling us to define plagiarism. Plagiarism is basically claiming another person's work. So claiming another person's work. And then copyright is basically when you to identify legal ownership. So meaning it's legal that you own it. That's basically what it means. Describe what is stored program concept. So what's a stored program concept? Basically instructions and data stored in the same memory. So you would say instructions and data stored in main memory. And then the other mark you would say basically comes from its name, stored program concept, meaning the instructions are fetched and executed one after the other. So instructions are fetched and executed one after the other. Okay. Describe the role of the program counter, which is basically the PC. So you can just write holds the next address, and also you can say of next instruction. I'll give you your 2 marks. Okay. Describe the role of the control bus. Control bus is used to transfer control signals. Well, the data bus, address bus, data bus will data signals, and address bus will basically locate the address or transfer the address. And this is done in order from the CPU. Actually, you can just write from CPU. Okay, so the control bus is located in the CPU in the von Neumann architecture. Okay, so that is that. Okay, so yeah, we move on. Computers based on von Neumann model for a computer system uses interrupts why interrupts needed. So interrupts is basically a signal, and it's used to identify or notify the processor so that it can stop whatever it's doing and do the following, and this to allow, you can say, multitasking, because it's done by the operating system, right? And one of the uses of the operating system is multitasking, and that marks the end of this paper, which was March 2021. It's going to be quite random actually, because I've done the May-June 2021 on my channel. If you see right here, I've done the May-June 2021 paper, which is right here. So meaning, let's do the variant 2 for the following. Okay, so let's get that paper right now. I will get the June variant 2 paper because I don't think I've done this one on my channel. Do not think I've done this on my channel. So we can do this on my channel. Have I done this on my channel? No, I don't think I have. Let's confirm that. Let's go in the place. I haven't done it. May-June 2017, May-June 2016. May-June 2020, and then October 2020. Yeah, so I haven't done it. Let's just enlarge it. So far, if you have any questions, feel free. Comment down below and I will respond. Do you guys prefer more of live streams or not? You can always let me know in the comments down below, but I don't know, it can be both effective. If you want to do live streams, you can do it together while I'm doing this, and if not, you can just always play the stream back again later on. So it's kind of the same thing, right? Yeah, so we're doing the computer science theory paper. Let's begin. How long have I been streaming for so far? Let's see. About an hour. Okay, let's see. I'll see how long this live stream is. Honestly, I don't have a targeted goal. Let's just see. Let's see where this live stream takes us to. Okay. We will see when the time is to come. So yeah. Okay, so let's go. First question. First question is on, again, hexadecimal and binary. It's always usually this, right? So okay, so yeah, so converting, let's see, converting denary to hexadecimal. Let's start off by converting that. Yeah, so we start off by converting the denary value to the hexadecimal value. So let's start by doing this. To convert, for example, 49 into hexadecimal, what you're supposed to do is you're supposed to multiply, basically it's 116. Yeah, usually it's always 2, so you're supposed to do 9 times 1 plus 4 times, wait, is it 1 second. Okay, let's see. Actually, I like usually to work with binary because it's more simple. Because for denary, actually we have to divide by 16. It's a whole lot process, because it's a weird process, right? So let's first convert to binary. To convert to binary, it's quite simple. You use the same thing that I did previously: 1 2 4 8 16 32. So for 49 it will be 32. So let's see, 32 plus 16, 8 4, so 48. Yeah, we'll need that. So we'll need 16, and then we'll need 1, so that'd be 0 0 0 and 0. So 8 bits, so we need to 128 here, so that's 0. Okay, so it'll be 0 0 1 1 0 0 0 1. Now personally for me, I like to work with binary and then maybe convert to hexadecimal. It's your choice. I like to personally work with binary. You can convert it to anyway, because if it tells you to convert from, for example, let's say from denary to hexadecimal, you can always, like this question right here, actually you can always convert to binary even if it's not asking for binary, and then convert to hexadecimal if maybe you are more comfortable with working with binary. So that's how you can do it. Actually, you're just cheating the system. Meaning you don't need to know the conversions of everything. You can just learn how to convert everything from binary and from binary to the other one, and that's a simple trick you can learn. So let's see. So to convert from hexadecimal here, so it'll be 1 here, and it'll be 1 2 4 8, so it'll be 3 here. Okay, if you don't understand how I did that, made many videos on hexadecimal and binary and all that sort of stuff, so go and have a look at that. So let's drop all of this. Let's again start off with 1 2 4 8 16 32 64 128. We're making 123, so we'll need 64. Of course we'll need 64. Okay, let's see. Will we need 32? I think we will be needing 32, because 64 plus 32 is actually 96, so we'll need it. Okay, and then 96 plus 16, let's see if we'll need it. That will be 2 1 10 11 twice, so we'll also need that. And then we have what, 8 plus 3, what's 8 plus 3? 11, so we have 11 left, so that will be 8 plus 2 and then 1, right? The rest will all be zeros. So this is how you do it, binary. So that is how you do it. If you don't understand, made quite a lot of videos on that, so that's how you can do it. Now I split this into 4 parts, right? 1 2 4, it's already written the first one, 1 2 4 8. Everywhere there's 1, I add it to 1 2, what's 12, 10 plus 1, so 11, so that's B, right? So that's B right here. And here will be 1 2 4 8, that will be 4 plus 2 plus 1, which is 7, so the answer will be 7B. Okay, we move on to the next one. 200, the much more larger one. Okay, so it's the same thing, 6 marks. You can see it usually comes with a lot of marks. Okay, so 128, of course, we'll need 128. Then 128 will be added to, let's see, can we add it to 64? Let's see. So 128 plus 64, that will be 12, 3, 9, 192. Yeah, so we'll need 64. Then we'll need only 8 more, so that the rest will all be 0 except 8. So that'll be 1, 1, 0, 0, 1, 0, 0, 0. Okay, there you go. And then let's convert it to hexadecimal. So you split into 4 parts, 1, 2, 4, 8. 1 plus 8 is 9. So I just write 9 here. Oh, is it? Sorry, it's 8. It's 8 here because there's only 1 under 8. So it's 8. And here it will be 1, 2, 4, 8. 8 plus 4 is 12. 12 is C. Yeah, A is 10. B is 11. And C is 12. So it becomes C8. So yeah, that's how you do it. I'll give you 6 marks right there. Okay, 2 benefits of users of converting binary values to hexadecimal. So number 1, easy to find errors. Because of course there will be less values, so you can find an error quicker. And then you can also say easier to read or easier to understand. So easy to read. Okay, I'll give you easy 2 marks right there. Hexadecimal is used to represent hypertext markup language, which is basically HTML. Color codes in computer science identify 3 other ways that hexadecimal can be used. This is just basic stuff. So you can write memory dumps. You can write this HTML here done. We can write MAC address. Okay, it's used in a MAC address, and you can also say it's used in IP addresses. Not all IP addresses, actually. There's 2 types of IP addresses. Right now I can't recall it, but there's a static IP address where actually it uses binary. So there's a difference. Okay, but I think you can write IP address. But in the exam, maybe if you want to be safe, you can also write URL, or you can write assembly language, something like that. But IP address would give you the mark. According to the marking scheme, it will give you the mark. So don't you worry, right? Don't you worry. Let's check the comments. Thank you, Code 4. Your videos are also really good. Actually, I watched some of them. So thank you for your content too. Okay. Thank you for your content too. So yeah. Number 2, it says data storage can be magnetic, solid state, or optical. 6 statements are given about data storage, and you're supposed to tick to show if the statement applies to magnetic, solid state, or optical storage. So in this, the main objective is basically to read about each of the following, and you just need to know the properties of magnetic, solid state, and optical. Okay, that one, there's no any shortcut out of it. You need to know what a magnetic is, how it runs, if it has moving parts, how it stores data, the capacity, does it consume power. You need to understand about magnetic. So my advice is always, before going to past papers, before just running towards past papers, because nowadays, people just go to past papers because maybe if you're having your mocks and you know that your teachers are setting through past papers, all you're doing is just cramming the marking scheme, which there's no objective to that. You need to understand how to do the papers. I know some people actually learn by doing questions, which is, that's your method. Yeah, so if that works for you, then it works for you, I guess. Hello, Soban. So yeah, let's see. No moving parts are used to store data. So no moving parts are used to store data that is solid state. Magnetic and optical do have moving parts. Like optical are CD, DVDs. So those ones move around, right? So it can't be optical. Then we have pits and LANs are used to store data. So pits and LANs are used to store data. So basically pits and LANs are used to store data is optical. Then we have data is stored on platters. Data that is stored on platters is always the magnetic one. Flash memory is used. In the previous paper we actually talked about flash memory, which was solid state. And then parts are rotated to store data. It's here. You see, because it's actually a trick, because it's saying no moving parts, we know it's solid state. So moving parts will be magnetic and optical. So that's a quick little mark there. Data can be stored permanently. Now that can be all of them, right? That can be all of them. You will get a mark according to the column. So if you miss out one of the ticks, you will not get a mark. So it's quite, sometimes the marking is quite strict, but that's how it works. So I guess that's That's computer science. So you have to get all of them. So, my advice for you for all of them would be to have a look at each and every one of them. Have a look at all of the options, and then according to those options, tick the one that you need. Okay. Give one example of a magnetic storage. There are many of them, but the main common one that we have also we've been learning about SSD and HDD, right? So you should be knowing about HDD, which consumes a lot of power, but it's a magnetic storage. Okay. We move on. Give one example of optical storage. I previously mentioned, we said we have CD, DVD, Blu-ray. We have learned 3 in the syllabus. You can mention any. CD and DVD have red laser, and Blu-ray has blue laser. That is the difference between the following, in short terms, but you need to read on all of them. So the trick to these storage devices is you need to understand each and every one of them. Okay, so we're looking at in terms of storage, you need to know which one stores the most, which one consumes the least power, which one consumes the most power, which one is more reliable, which one has more moving parts, and all of that stuff you just need to revise, and then past papers become much more easier. Okay. It says identify which type of storage would be most suitable for use in a web server and justify your choice. So web servers, which type of storage in a web server, you would say maybe HDD. Okay, I would say HDD. Why HDD? You can also say SSD. Actually, can be any of them. HD you can say because of course a web server receives many requests a day, so that can be handled by the HDD. So requests receives many requests a day, so hence the HDD will be more suitable for that. And you can also say magnetic. Okay, the magnetic storage devices are always cheaper, so magnetic is cheaper compared to any of the other ones. Okay, it's more cheaper per unit than the solid state. Okay, and there's no requirement for it to be portable, neither does it have any problems with moving parts, hence it doesn't matter, because a web server, it doesn't care about moving parts, right? It's not moving around anyway. Portability, we don't care because it's a web server, it's stationary at one point. We just need to program the web server, so we don't need anything apart from that. Okay, so yeah, that is that. We move on. Describe the operation of a USB flash memory and how it stores data. So USB flash memory, I think it's telling us basically to talk about basically it's telling us indirectly this is SSD, because SSD uses flash memory, right? So you just have to tell us the properties of SSD, and it uses NAND. We did this in the previous paper. It uses NAND technology. Then you can say it uses transistors. I also mentioned it in the previous past paper. So you can see how everything just is repeated. You can see how it's repeated, and then you can say data is flashed onto chips. Okay, I'll give you also mark that 3 marks, so 3 points. We move on. Let me just minimize this so you can see the statements actually. Okay, so here we have a statement question, and we are supposed to basically draw the logic gate to represent the given logic circuit. A quick tip, look at how many marks it is. 6 marks, meaning 6 logic gates. That is how you understand. Okay, let's see. Do not attempt to simplify the statement. Okay, let's start off. We start off not A, B. So we start off with there. That means not A. Okay, and we are joining this with an AND gate. Okay, sorry for the terrible drawings again. I'll keep reminding you. So this one is done, and this one is joined by an OR C, so we can join this with an OR gate. Okay, so this one will be joined by an OR gate. Oop, really bad OR gate. That's done, and this then is joined by an AND gate with B. This is joined by an AND gate. This is done. Then this is joined by a NOR gate of B or C. So B or C. Then you join this together to create your NOR gate, which has the circle on it. And there you go, you're done. Is that 6 logic gates? Yeah, that's 6 logic gates. And that's correct. Sorry for the messy diagram, but that is how you do it. Okay, now it's telling us to what is this, working space, and we have to identify whether it's right or wrong. I'm not sure if I've done the same question on my channel, because I've uploaded a video just on logic gate, so you can have a look at that if you're interested into that. But how I do these types of questions, so let's see what I do in these types of questions. I label each logic gate, so that's how I do it. So this is 1, this is 2, 3, 4, 5, and 6. It doesn't matter with how you order it. Then I will divide this columns into 6, because we have 6 logic gates, or 5 is also fine because the last one is X, and then 4, and then 5, and then 6. Okay, so let's see, number 1, we talk about number 1 first. Number 1 is not A. So not A meaning the opposite of A, so it'll be 1, basically be this. Okay, that will be the first one. Then 2 is B or C. So we do B or C, meaning we add B and C. So it'll be basically that. And then number 3 is 1 and B, and it's an AND gate. So we're multiplying 1 and B, and we're multiplying 1 and B. So it becomes 0, 0, 1, 1, 0, 0, 0, and 0. Should be right, but if there's any mistake, we'll see in the end. 4, it's 3 and 2, and it's it's C. It's C and 3. So C and 3 is joined by an OR gate, so C and 3. So we add C and 3, so that would be 0, 1, 1, 1, 0, 1, 0, 1. There you go. Number 5 is saying it's joined by 4 and is joined by B. So we're joining 4 and B, and this is an AND gate. So we're looking at B and we're looking at 4. So here it'll be 0, here it'll be 0, here it'll be 1, here it'll be 1, here it'll be 0, here it will be 0, here it will be 0, here it will be 1. And finally, the last one, hopefully nothing is wrong so far. We're joining 5 and 2 with a NOR gate. So 5 and 2 with an OR gate. If it is an OR gate, it will be 0, 1, 1, 1, 5 and 2, right? Was it 5 and 2? Yeah, 5 and 2. So if it was an OR gate, it would be this 5 and 2, 0, 1, 1, 1, 0, 1, 1, 1. But it's a NOR gate, meaning it should be the opposite, meaning it's 1, 0, 0, 0, 1, 0, 0, 0. So this should be the correct one. Hopefully we haven't made any mistake, because if we have, okay, so this is correct. Oh, this is wrong, this is wrong, this is correct. This is wrong, this is wrong. So yeah, I think it's correct. So 2, 3, 7, 8 is wrong. Yeah, there you go, we've done it. So the answer right here is this. So this is the answer. This was the OR gate. And to get the NOR gate, I do the opposite of the OR gate. That's why, it's a bit messy. So this is the correct one. So 6 would be 1, 0, 0, 0, 1, 0, 0. And the question is asking which one is right, which one is wrong, sorry. So this one's all right, except row 2, row 3, row 7, and row 8. Did you guys understand? Logic gates is a question that it looks hard, but it's actually really easy. Looks hard, but it's easy. Okay, so yeah, this it's a really easy topic. Actually, it's not easy. It isn't even that hard. Yeah. Okay, number 4. Number 4 is saying 3 types of internet security risks are virus, spyware, and denial of service attack. Now, DOS, people don't really revise it, but it's actually tested, quite common. So people forget to revise this. But DOS, you need to know. DOS is many requests sent to the web server until it crashes because of how many requests there are. That's what the denial of service means. So here we have 6 statements that are given about the internet security risks. we're supposed to tick to show whether the statement applies to viruses, spyware, or denial of service. And some statements may apply to more than one security risk. So let's see. Viruses, let's see, captures all data using a keyboard. No, that's actually spyware. That's actually done by spyware. Can be installed onto a web server. That can be done. A virus can, spyware can. Prevents access to a website. That is a denial of service attack. A malicious code is virus and spyware. Okay, can't be denial of service actually. Self-replicating, we know that's a virus, only virus, and damages the files on the user's hard drive. That is the virus, because the spyware just basically monitors the key presses. Okay, so that is that, and then yeah, so that's that. So that is gonna give you your 6 marks. Now the next question is identify 3 other types of internet risks. We have so many actually. We have you can say hacking, you can say phishing, you can say farming. Yeah, so hacking, phishing, farming. I'll give you your 3 marks. Phishing, farming, it's like always write phishing, farming, man. It's never wrong. So yeah, but there are many other security risks, but I think these are the ones. So some internet security risks can maliciously damage data, and data can also be damaged accidentally. So basically we have, it can be maliciously damaged, and data can also be damaged accidentally. State 3 ways that data could be accidentally damaged. Number 1, you would say by mistake. So you would say basically the user's human error. So you would write human error. Then you can also write power outages. That one will give you something. So power failure. And then you can also say fire or something like that. Fire or a flood or something like that. Now, microprocessors, my favorite question, because it is 8 marks and it's literally the most easiest question in this whole paper. 8 marks and it's the most easiest. So my objective is to get you all these 8 marks. Okay. In total, this question is 10 marks. Can you believe it? And this is one of the easiest questions. This question and what is it called? Parity checking. What is it? That is the easiest questions that you can ever get in computer science. You can never miss those questions. Never miss those questions. Okay, like they're really simple. Okay, and if you don't understand them, don't worry, I'm here. I've actually done many of those questions. Go have a look at those past papers. Also, I'm planning to put chapters into my past paper videos so that some people that come just for a particular question can go have a look at it and leave. So yeah. Easy question. Number 5, it says a security light system is used by a factory. Okay, and the light only comes on when it is dark, and when the movement is detected, the light will stay on for 1 minute before switching off. It then says sensors and a microprocessor are used to control the security light system. So sensors and a microprocessors are used to control the light system. It says identify 2 sensors that would be used in a security light system. The first one, okay, because it's a light system, there should be a light sensor. You see why I'm saying it's easy? You see why I'm saying it's easy? If it's a light system, you'll need a light sensor, wouldn't you? Okay, and if it is talking about movement detected, what will you need? A motion sensor. It's so general knowledge is this question. It's so general knowledge, like you can't miss out on this. You just cannot miss out on this. Okay, so B, this is the question that has the most marks, the most demanded question. I don't know why the pen color changed all of a sudden. Was it blue or whatever it was? I think it was this. Okay, yeah, I'll put this back. Describe how the sensors and the microprocessor control the security light system. So before we write this, let's discuss this. Okay, let's discuss this question. Okay, because we've been writing this entire live stream almost. We're really talking and and just having a look at that. So let's understand this question. Okay, first of all, for these questions, you need to understand what the question is asking for. Okay, you cannot write your own values and stuff like that. This question particularly, let's highlight it actually. Okay, let's highlight it and then let's plan it first, because it's 8 marks. Okay, and if it's 8 marks, you spend some time on it because you need to get all those 8 marks. Okay, so let's see. A security light system is used by a factory. Okay, so the first keyword, it's a security light system, so you cannot talk about pressure sensors. Okay, or unless actually you can well, you can't talk about temperature sensors, for example. Okay, okay, so basically you cannot talk about, for example, security light, sorry, you cannot talk about temperature sensors or something like that. Okay, you basically have to talk about something related to light sensors. Okay, with that being said, then the next clue is the light only comes on when it's dark. You see that? When it's only dark and when the movement is detected. So that's your next prompt. That sensor will only come when it's dark and when there's movement detected, and the light will stay on for 1 minute before switching off. Okay, you've understood the prompt. Now let's do the planning. 8 marks meaning 8 points, and 8 points is actually a lot of points if you think about it. Getting 8 points in a microprocessor question is a lot, but I'll make your life quite simple, because most of these microprocessor questions, they follow a sort of order that you need to understand. Okay, and let's take some time into this question actually, because you need to understand this question. Okay, you may think maybe sometimes these questions are quite simple, but you need to understand how these questions work. Okay, first of all, you have to talk about the sensor. Okay, you have to talk about the sensor. So the first thing, you have to talk about sensors. Secondly, you have to talk about microprocessors. Without microprocessors, you cannot get your marks. The next thing, you have to talk about something called the ADC, which I'll later on explain if you don't know what ADC is. You then talk about the values, like for in this case, when it's dark, when its movement is detected, when 1 minute light before switching, you have to talk about the values. Then you have to talk about the action taken, or what is the action that's going to be taken when these criteria are met. Then you talk about something called the actuator. Okay, the actuator which we talked about in one of these live streams is basically detects physical movement or movement basically in general. Okay, or performs movement. So an actuator is that. Okay, and we have to talk about what the actuator can do. So in this case, the actuator can maybe switch on the light or switch off the light, okay, after 1 minute. And then finally, you have to say repeat. That repeat will give you 1 mark, believe it or not. That repeat can give you 1 mark. Not a must, but it can. Okay, and that's how you approach a 8-mark question. Okay, and take your time, because you need to get every 8 mark, because this question is really easy if you capture all the elements of the question. So let's do this. Sensors, microprocessor, ADC, values, action, actuator, and repeat. So this is the format I would look at to a microprocessor question. If it is 6 marks, then you would just say microprocessor, ADC, values, and action, and repeat, or something like that. But even if it's 6 marks, there's no harm in mentioning all of them. You won't get a mark for writing too much. Okay, so let's see. Let's drop this. Now let's go through each point one by one. Okay, let's go through each point one by one. So let's see. Number one. Start off. Number one. I said sensors will send the data to microprocessor. Okay, that will give you your 1 mark there. Done and dusted. Okay, sensors send the data to the microprocessors. Now, what will that microprocessor do? Let's see. Now we talk about that. That's why our step was sensors, then microprocessor, right? Then data, okay, that data that the sensors have given, okay, data is converted, okay, to digital using ADC converter. The ADC converter, coming from its name, converts analog data, which is sent by the sensors, into digital data. Okay, so this data has to be converted into digital so that that microprocessor can read it. That's your second mark there. Your third mark. The microprocessor will compare the data or the with the preset value. So you write that. So the microprocessor compares data to stored value. So the microprocessor will compare this data with the stored values. Now, to get your other marks, because it's 8 marks, you have to mention these values, okay? You would say, if value is out of the range, okay, that means if it's basically, not in the range, then you can say the microprocessor will switch off the light. Or okay, actually, let's say if it's in range, okay, because if value is in range of what the criteria is, if value is in range, then microprocessor sends the signal to switch the light on, That might even give you 2 marks, we don't know, but we'll just be safe. Okay, that will give you 1 mark. I think that will give you 2 marks there, but we see. You can then say maybe a 1 minute timer is then started. You can also mention that, okay, that can actually give you a mark. 1 minute timer starts, because in computer science they test how you interpret data, how you think about it. Okay. Hello Nam, hello, welcome to the stream. So basically that will give you 1 mark there, saying 1 minute timer starts. That will give you that mark, that 1 mark there. Then after that you can say once timer finishes, you can say once timer ends, you can say something like that. So once when timer ends, then microprocessor whatever sends signal to switch off. Okay, and this is done by the actuator. You can always just mention this, done by the actuator, the switching off lights and all. And then number 8, whole process continues, because it is 24 hours of detecting it. So that will give you another mark. That is how you do a question like this. Okay, that is how you do a question like this. 8-mark question. Take your time, analyze it the way I analyzed it, and yeah, that is basically how you do it. Okay, yeah, we move on to cookies. It's not tested that often, but it's tested, so you have to revise cookies. And if you notice, actually computer science, it doesn't have that many topics if you think about it, because there's only 8 chapters. Okay, it has 8 chapters, and we have maybe like 5 topics per chapter, so it's not that many topics actually. So I believe you can even do the entire CS in a very short time compared to other subjects, because computer science, if you don't understand the basics, I think then maybe you can have a problem. But don't worry, yeah, even if your exam is in Feb March, you'll do it. Okay, just go through your textbook, go through YouTube videos, not only mine. There's so many other videos out there, and yeah, just keep uploading. I mean, sorry, keep basically being consistent with your revision with computer science. Okay, and then you get there. I don't know how many of my viewers actually do the Feb March series, but it would be an interesting poll. How many are doing the 11th February exam, which is in a few days, 3 weeks from now, paper 1, I think. So that's why the main purpose of this live stream was so that you can have a look at basically that. Okay, so we move on to cookies, right? Let's not waste time. Cookies can be used to store a user's personal data and online browsing habits. Okay, a cookie can be used to automatically enter a user's payment details when the user makes a purchase online. Describe how the cookies can be used to store and automatically enter a user's payment details. So basically we have to describe how cookies work. So cookies work by, first of all, the web server sends the cookie file to the browser. So web server, okay, sends the cookie file to the user's browser. Okay, once when this happens, then the cookie file is stored by the browser. Cookie file stored by browser. And then lastly, the next point you can say is when the user revisits, you can just talk about that. When user revisits the browser, then it's stored here from before. So when it store the web requests the file. So basically when the user comes back, the web server can request that file once again, so that you can basically see the file that was stored. Basically cookies stores your data, right? As it's saying here, stores personal data. So when you come back to a website, that's the reason that when you come back from, maybe like if you use a website more like quite more frequently, and if you've noticed, maybe like once you haven't put the password, because of cookies, and usually it actually asks you that this web server or web browser uses cookies, and you have to accept that they use cookies, because technically they are looking at your personal data, right? Technically they're storing what you're browsing, so they have to ask permission. That's how web servers steal data. You don't know, but what's happening behind the scenes, you don't know how they steal the data, but that's how they steal data. Yeah, that's how they steal data. Now it says, explain why a user may be concerned about their personal data and online browsing habits being stored in cookies. This just exactly what I was talking about. Like you have no option, right? Because like even websites with like Amazon, all those big websites, Wikipedia, Google, all of them, they have cookies. That's why when you search something that you've searched before, it's there. Okay, meaning they are taking your personal data, what you've searched before, but it's unavoidable, right? Because everyone's using it, and I think that's how cookies work. The main reason for cookies is for your benefit, but I don't know, it's debatable. So let's see. Explain why a user may be concerned about their personal data and online browsing habits being stored in cookies. So let's see. First of all, the user doesn't know what they're storing, right? So user does not see what information is stored, what is not stored, what is stored. We don't know what that is. And then secondly, the privacy may be affected, right? Privacy may be affected because some people, maybe they want to search something, but they don't want cookies, right? They don't want people to see what they search, whatever it is, regardless. Maybe bank details, maybe something like that. They don't trust the site. Okay, then you can also say sensitive information can be stored. Because, for example, in some of these websites, right, when they tell you to order something online and your details of credit cards is already there, it has sensitive information, which can be kind of, risky. And then finally, you can say other websites could gain access to those cookies. Other websites could gain access to the cookies. The cookies stored. I have a question on HTML structure presentation. This question is also quite tested a lot. Many people may start to revise on this. Basically, give an example of an HTML structure. You would say margins. An example would be margins. For presentation, you can say there's actually a lot. You can say fonts, color, font style, all that will work. Explain why Jolene separates the HTML into structure and presentation, so that you can edit. So you can edit the web page later on. Okay, and you can also say you can reuse the presentation. You can reuse presentation style. Okay, a keyboard is a type of input device that can be used to enter data into a computer. It says complete the paragraph that describes one method of operation for a keyboard using the most appropriate term. So let's see, a keyboard has a key matrix under the keys. When a key is pressed, it presses a switch, right? It presses a switch. Okay, if you know about keyboards, you would know it's a switch even without doing computer science. That completes a circuit. I was about to say series, but I don't think there is series, so circuit is the one because I see it right here. Circuit. This allows, actually I don't even need to read the options. Sometimes these even like when they set the question, like in previous other papers, they set it in the same wording, so that's how you can just predict. This allows current to flow. Okay, and the location of the key pressed is detected. Let's see, is that corrected? No, it's calculated. Okay, calculated. Similar, almost similar actually. The location of the key pressed is compared to a character map. Yep, it's the character map to find the binary value. Okay, because if actually keyboards use hexadecimal, but there's no hexadecimal here. A CG code, or a CG code. If you've read about a CG code, you know about hexadecimal, right? You know about hexadecimal, and yeah. So basically, that is that. I think I'll mark the end of the live stream because we've done 2 papers. We did an in-depth actually tutorial because usually I finish a past paper in 30 minutes, but in today's video I actually explained it really precisely. That's why it is quite long. So yeah, with that being said, I think we'll call that the end of the live stream. Thank you for watching. Thank you for the support of everything, and I'll see you in the next live stream or next video. I'll see you in that video. So thank you for watching this video, and I'll see you